In the interests of the safety of the aircraft, people on the ground, and that of the pilot, many precautions have to be taken before and after flight. We'll begin with the pre-start situation. The aircraft should be sighted on firm level ground, free from loose stones and litter, and servicing equipment that might be damaged by the slipstream. Where practicable, the aircraft should be heading nose into wind and so positioned that the slipstream is directed away from other aircrafts and buildings, and that there is room to taxi. The brakes should be applied, or alternatively the main wheel should be securely chocked. All covers and blanking plugs must be removed before starting the engine, and all access panels and hatches must be securely closed. The engine oil contents should be checked to ensure that there is sufficient oil for the planned flight. Some aircraft have the oil dipstick integral with the oil filler cap, so make sure that the filler cap is secure after contents checking or replenishment. Look for signs of oil, fuel, or hydraulic fluid leaks. Check that plug leads and priming lines are secure. Once the check inside the cowlings is finished, make sure that the cowlings are closed and the catches are secure. The propeller should be checked for damage. Make sure that there are no nicks or cuts on the blade. Check that the spinner is secure and undamaged. Treat the propeller with a great deal of respect at all times. The results of the engine firing just once could be fatal if you are in the way of the propeller blade, so stay out of its arc and don't touch it or move it unnecessarily. If you have any assistants to start the aircraft, make sure that those individuals involved are thoroughly conversant with the procedures used. Also ensure that they're not wearing loose clothing that may get tangled in the propeller or blown about the airfield in the slipstream. Now let's look at engine start. Bear in mind that the advice given here is general. It doesn't apply to any particular aircraft type. Initially, prime the engine with the recommended amount of fuel for the prevailing engine temperature. Being too generous with the priming may cause trouble for you later. Firstly, it may flood the engine and wet the plugs, which will definitely not help the engine to start. And secondly, it could also put fuel into the induction system, which may start a carburetor fire if the engine backfires. This is potentially a very dangerous situation. If you are unfortunate enough to have a carburetor fire, keep the engine turning over on the starter motor, put the mixture control to the idle cut-off position and open the throttle. Turning the engine over will tend to suck the flames into the cylinders where they won't do any harm. Selecting the idle cut-off will starve the fire of fuel, and opening the throttle will make it easier for the engine to suck the flames into the cylinders. Continuing with the normal start, set the mixture control to the rich position and set the throttle just open. In the interest of safety, it's best at this point to check that the area around the propeller is free. Making sure that all in the vicinity can hear you, shout, "Clear prop!" Now turn the magneto starter switch through to the start position. Most aircraft starter motors have a limitation on how long they can remain energized. Make sure you know that limitation, and be sure that you don't exceed it. As soon as the engine is running, release the start switch and immediately check that the starter warning light is out. If the starter warning light is still illuminated, stop the engine immediately. Now check the engine oil pressure gauge. If the oil pressure doesn't rise within 30 seconds, stop the engine immediately. The engine should now be allowed to warm up until minimum temperatures and pressures are obtained before the throttle can be opened. This warming up is done at the recommended RPM stated in the operator's handbook. This is a convenient time to check that the aircraft systems are functioning satisfactorily. For example, check that the fuel pressure is within limits and that the suction system is providing the correct amount of vacuum. With the throttle still set at the prescribed slow running RPM, the dead cut check can be carried out. This check is endeavouring to ascertain whether the two magnetos are both working under your control. Select each magneto in turn. Check in each case that there is a drop in RPM, but that the engine does not stop. If the engine does appear to fail when either magneto is selected, allow it to stop completely. Don't be tempted to select the magneto switch either to the other magneto or back to the both position. This could possibly cause mechanical damage to the engine. Now check that the engine pressures and temperatures are within the green, or at the very least, the yellow sectors of the gauges. Change the fuel tank selector to the other tank, and set the throttle to the correct RPM for the magneto check, usually around 2000 RPM. Check the carburetor heat now. You should note a drop in engine speed as it's selected on because the engine is receiving hot, less dense air, so the mixture has been made richer by your selection. The RPM lost should be regained after carburetor heat has been deselected and once more cold air is being fed into the carburetor. Now on to the magneto check proper. The magneto check is carried out to make sure that both magnetos are functioning correctly. As each magneto is switched off in turn, check for a drop in RPM. This drop must be within the limits laid down by the manufacturers, and the mathematical difference between the RPM drop of each magneto must also be within a tolerance figure which is given once again by the manufacturers. The fall in engine speed is due to the fact that as you switch off a magneto, you're essentially switching off a plug in each cylinder, thus increasing the time it takes for the mixture to be fully consumed within the cylinder. If no drop in RPM occurs, then this may be indicative of the fact that the deselected magneto has not been deselected, or it may be that it wasn't working in the first place. However, that should have been noticed during the dead cut check. An excessive RPM drop when a magneto is switched off may be indicative of any of several problems. For instance, the plugs of the remaining magneto may be defective or just fouled. If fouled plugs are suspected, then it may be worth leaning the mixture off for about 10 to 20 seconds to clear them, and then resetting the mixture to rich preparatory to trying the check again. After completing the magneto check, check the aircraft systems once again. Note the engine oil temperature and pressure gauges and the low oil pressure warning light. Ensure also that the fuel pressure is within tolerances and that the suction vacuum is sufficient. After checking that the alternator is still online and that the ammeter reading is normal for the load selected, close the throttle and note that the engine idles at about 600 RPM, and then set it to the recommended idle speed, usually about 1200 RPM. Setting the throttle at this level prevents the plugs becoming fouled during prolonged idling. Get used to operating the throttle lever smoothly. Jerky or rapid movement of the throttle lever will not make the engine respond any more quickly. In fact, it may cause the engine to hesitate or stutter because of an overweak mixture. Engines have been known to stop because of a weak cut caused by a rapidly open throttle. Count slowly up to 3 while opening the throttle from idle to full power. You'll find that the engine is accelerated at about the same rate as the throttle lever is moving, which is about as fast as it can respond. The same practice should be followed when reducing power, especially when throttling back from takeoff power settings. Smooth operation of the engine controls will allow time for mixture strength and charge quantity to change in line with the engine's requirements.